Hey guys, Bobby M back for another video. This one's going to be a follow-up to the mash tun and software calibration video I did a couple weeks ago. And I'm going to be taking that data that I collected that day and inserting it into Beer Tools Pro so that it has better information on calculating the strike water temperatures in order for me to hit the ideal mash temperatures and things like that. And I'm going to show you, what the effects are with choosing different heating vessels for your strike water and so on, and how the BTU, effective BTU of the burners plays into the overall heating time, and how the software tells you some information about that as well. All right, so let's get started. So the first thing I want to do is make sure I have some kind of malt on the ingredients list, and I just put in 12 pounds of 2-row just so that I can show you the relevance to how it plays into the schedule. So then I'm going to go to the drop down here and select vessels. Now when you first start setting up your Beer Tools Pro application, you're not going to have any vessels populated here. I set these up ahead of time, but as you start building your vessels, you're going to want to right click on this area here and select new vessel, and it's going to bring up a blank window where you can input all the specs on your vessel. For now, I'm just going to open up my mash tun by double clicking and show you the details here. Now I noted that I actually performed a calibration just so that I can know later on that I didn't just spoof these numbers. All keg-based vessels have these attributes. It's a circular vessel with 15.5 inches width and length. That's the diameter. And then 19 inches of height. And if you input that, you'll get 15.5 gallons, which is correct for a Sankey keg. Your dead space, again, is individual. You're going to have to drain the water out and see how much gets left behind, and you input that number here. And then you perform the calibration steps that I talked about in that last video. You input the environment, which is 42, the infusion volume, which was 8 gallons, the temperature was 160, and then I measured the temperature at 5 minutes and 65 minutes, and I found 154 degrees Fahrenheit and 147. So once you do that, the heat capacity number is automatically calculated and populated here, and so is the heat transfer coefficient. And then you hit OK, and now you have your mash tun calibrated for the software. I also performed the same steps on my Sankey boil kettle, which is exactly the same as the mash tun, except it doesn't have any insulation in it. So the dimensional aspects are exactly the same, but I did a separate calibration step with these figures, and I set that up, and now it sets the heat capacity and the heat transfer coefficient separately for an uninsulated keg, and I'm going to hit OK for that. Now, my hot liquor tank is exactly the same as my boil kettle, so I just right-clicked on the boil kettle and hit duplicate, and then I opened up the copy and renamed it Sankey keg, hot liquor tank. So those two vessels are exactly the same. All right, so once you set those up, all your different vessels, you're going to go into the drop-down and select heat sources. Those are your burners, or whatever your heat source is. And again, when you're setting this up for the first time, you're not going to have anything in the list here, so you can right click and go new heat source. All right, I have 2 of them set up already with the information I collected. So I have my hot liquor tank burner. Again, it's 13 tips, and I input the environment, the calibration volume. I selected from this drop down which vessel I was heating, so that's the liquor tank. And then I entered the time it took to heat 18 degree deltas. Okay, so I have a couple different data points I collected that day, and I just kind of averaged it out to 6.5 minutes and hit OK. And then I did the same thing for the mash tun burner. If you remember, it was a slightly smaller burner with less tips. And then once you enter all that information, you're going to see that the effective BTU is displayed here. All right, so now that we have that information, the next thing we do is go down to the schedule tab here and make sure that you set the ambient air temperature to whatever it is, whatever it's going to be approximately on your brew day. So I'm going to say these days it's running about 40 degrees during the day. So I'm going to select that, and then I'm going to go over here to schedule. Now when you're first setting this up, you're not going to have anything here, but the first thing you'll do is go new mash in, and then you're going to get a window like this. And what you want to do is select all the different vessels you intend to use. So it's pretty intuitive. Mash vessel, I selected my Sankey keg mash water tun. My heating vessel is going to be my hot liquor tank. My heat source is the HLT burner. And my target temperature for the mash is 155. Let's say that the grist was sitting in the garage and it's going to be 40 degrees. And my infusion rate is 1.5 quarts per pound. So that calculates a 4.5 gallon strike water, and then the strike temperature is automatically calculated here based on all the different values that we've already input based on these vessels and their thermal characteristics, our desired mash temp, the grist temp, the ambient air, all that stuff plays in. So it wants me to put heat my water to 180, almost 181 degrees in my liquor tank, and then transfer it over to my mash tun with the grain. And if everything worked out right and you did the measurements right, you're going to end up exactly at 155 degrees on your mash. Now look how high that temperature is, 180 degrees. And the reason for that is that I'm heating in my hot liquor tank, and then I'm putting it into my mash water tank tun that is not preheated. It's cold, it's 40 degrees because it's been sitting in that ambient air temperature for that long. And it knows how much heat that vessel is going to take. So that's why that strike temp is so high. Now let's take a look. If you have a direct fire mash tun, let me change my heating vessel to the mash tun itself, and I'll put the heat source as the MLT burner. All right, so now look at the strike temperature. It went from 181 to 168.5. So that's quite a difference. Now you can imagine why, because as you're heating that strike water in that vessel, you are negating the heat capacity of the mash tun. In other words, you're preheating it all the way exactly up to the strike water temperature. So this is subtracting all of the losses that heat capacity would normally steal. Okay, now here's an interesting thing. Because I have my burners calibrated and it knows how much time it takes to heat liquids, let's just take a look at the heat duration. It's saying at 100% output with this burner, it's going to take me 45 minutes to heat that strike water up to 168, given my source water temperature of, say, of 60 degrees, which you can set on the schedule tab. If I go and select the hot liquor tank burner, and hot liquor tank is my heating vessel, look, it goes down to 26 minutes because the effective BTU is nearly double for that burner. So, you know, like I explained, one of the things I do is I actually split the strike water. So for 4.5 gallons, I might put 2.5 gallons in the hot liquor tank and 2 gallons in the mash tun and heat them simultaneously. And then at the very end, I'll move the water over to the mash tun completely and finish the heating, say the last 5 degrees, so that I'm fully subtracting all of that heat loss, but I'm also hurrying up how fast I can heat that strike water. All right, so I hope that helped you understand why you want to calibrate your vessels and use software and nail your mash temperatures from now on. If you have any questions, let me know. Thanks.